Hello, thank you for joining me today, joining me in a discussion about a digital transformation in an aged facility, particularly a manufacturing facility in Lexington, Kentucky. My name is Kenneth Labhart, and I'm the innovation leader for Schneider Electric in the supply chain performance group in North America. I have the cool job of being able to go around and work with factories throughout North America and help them in the adoption of our Smart Factory program, help them in the adoption of Fourth Industrial Revolution tools as it applies to improving their manufacturing operations. Now, I gave a similar discussion or held a similar discussion with this group last year about this facility and focused more heavily at that time on the Smart Factory program and how it pertained to the factory as a whole. I'd like to spend some time today diving a little deeper into some of the actual use cases and the explanation of how we apply those technologies to drive improvement in the facility. We are very fortunate and very proud here in the Lexington, Kentucky facility to be named or selected as a World Economic Forum Advanced Lighthouse here in Lexington, Kentucky. We were able to achieve this by showing evidence to the World Economic Forum of a digital transformation across the entire supply chain domain, all the way from our suppliers and through planning, procurement, through the make domain, through sustainability applications, and even on to our customers. And that was announced in September of 2020. It was the first end-to-end digital transformation advanced lighthouse within Schneider Electric. And I'd like to talk to you a little bit about the make domain and the sustain domain as it pertains to that certification here in Lexington and how we've driven benefit. Now, I always start these conversations and these types of discussions with a steal from a contributor to Forbes magazine named William Sundblad. I think this is probably one of the best definitions of a smart factory that I've ever heard. I'm going to read it because it's very important for the discussion. The smart factory evolution is about building upon the advancements of the third industrial revolution by automating the collection of data from machines and applications and transforming that data into immediate insights. This new technology turns the tedious but critical process of extracting insights from data into one that is instantaneous, streamlined, and achievable for every manufacturer. Now, the reason why I love this definition of a smart factory is because it doesn't get caught up in buzzwords. We don't throw around terms like artificial intelligence. We don't throw around neural networks. We don't throw around advanced predictive analytics. What we talk about at the heart of being a smart factory is to being able to extract and share data for immediate use. And those are the kind of things that I want to talk about with you today in the Lexington facility, how we were able to do that, and then further, an evolution of what you saw or heard from me last year in this type of presentation is how we're evolving and moving on into those higher order analytics because we've made that leap to connect and begin to extract that data. So I want to start with just a brief background about the Smart Factory program because it is the heart of the digital transformation here in Lexington. And our Smart Factory program began at a global level in 2017 with Schneider Electric, and we underwent a sprint in 10 factories covering 6 months, where we invested rather heavily in new technologies with the intention of connecting our factory floors, sharing data, knocking down silos of information. Some of the more advanced features like augmented reality, artificial intelligence. It was a controlled effort to develop a tool set or a tool bag of digital tools that we could take and scale throughout our factories globally. And in 2020, we had 80 factories that were deploying their digital transformation roadmap, and we have that same number this year that are deploying an evolution of that tool set. And we also have now criteria of advanced and standard levels, with the advanced levels working more into the higher level Fourth Industrial Revolution technologies like artificial intelligence. But the intention here is to develop to prove which technologies we could scale and take throughout our facilities to drive improvement. And as a result, okay, we developed what you may call a digital tool bag. Now, I'm not going to walk through each one of these individually, but this is the standard digital tool bag that we're seeking to take throughout the globe and help plants solve problems in their factories through digital transformation. A lot of these tools deal exactly with the data extraction, data management, to make rapid decisions in terms of machine health, process health, quality, and performance of those processes. So we took this solution set and we sat down with the Lexington team actually in 2019, and showed them this tool set and asked them for their problems. Now, I'm not going to lie, or I would be remiss if I didn't talk about some of the problems that we ran into here, both at a global level and also a local level in terms of digital transformations. I hit some of the most important ones here. It's very difficult to give exact details in how we overcame these types of problems with the digital transformation and the adoption of that tool set here in Lexington. But what I do want to talk about is I want to hit the high points on some of these, and particularly the first one being employee pushback or culture. Anytime you introduce new technologies, new methods of doing things to people on the factory floor, or even in management or any level of your organization, there's going to be pushback. If you think you can give a person a new technology, walk away from that person, and not continually re-engage and take the fear of that technology away, you're mistaken. And we learned that very early on, and constant employee engagement and training and taking that fear away, the technology was very vital in helping us overcome that employee pushback and culture. It's very important that you have executive leadership from the top down, from buy-in from the top down on a digital transformation. The support of the cyber awareness, the support of the digital awareness, the tools, the adoption of those tools. It is critical that that's driven from the top down. Otherwise, it's just lip service. And we're very fortunate within Schneider Electric to have executive leadership buy-in from the top down, driving our digital transformations. Cybersecurity, we're going to touch cybersecurity a little bit later in the discussion, but we also learned early on that there is a big difference between knowledge in the informational technology layer and the operational technology layer. And we're going to talk about how we dealt with some of that on the factory floor. Digital expertise, it's no great secret that it's hard to find the exact people that know these technologies and new technologies and how to apply them. What we did in our company is we identified those that we wanted to develop as subject matter experts with a good background in the basics of electronics, of OT layer processes and machines, and then we developed and trained those people through a rigorous global program, Smart Factory program, of disseminating ideas and knowledge to help develop that digital expertise in our operations. Digital infrastructure. The examples that you're going to see here in Lexington, there was a sizable commitment in the infrastructure. We had a lot of Ethernet backbones. Our Ethernet backbone was mature. We made the commitment to connecting our equipment, to connecting our processes, and putting in the possibility of expansion. That's something to consider, and it's something that is really a mainstay, or it's one of the basics of the industrial Internet of Things, is the ability to connect your processes and equipment. Business justification and budget. Often difficult to understand or to communicate why we should spend money on something, or why we should invest in a new technology. We approached this with that first sprint in those 10 facilities over 6 months, where we documented the types of improvements that we could drive with those technologies. And then we used a bit of extrapolation to extrapolate what we could drive in the rest of our operations to justify those to justify those budgets. This is very closely tied with that executive leadership buy-in. You know where you want to be in the future, and you know what the future is going to look like. You drive to get to there. Okay. Now, this all adds up to a very complex situation. It was not easy. It's not easy. It's a battle in each one of these, but a battle that can be overcome. And I think probably the thing that I stressed last year was starting small. So I'm going to talk about how we started small in Lexington, and then we're going to move to the evolution of those things. But it's easy to get caught up in this discussion and the reasons why not and the problems. It's very important to take small steps and move quickly. Let's give a little background here, a little talk about the Lexington facility. So the examples that you're going to see concern the Lexington, Kentucky facility, which was built in 1957. We've got about 500,000 square feet of operating space in the Lexington, Kentucky facility. We make load centers and safety switches. Energy distribution control in residential, commercial, and industrial applications. And the facility is very heavily vertically integrated. So all the processes that take place here, the stamping, the painting, the plating, the injection molding, and the material handling, and even the semi-automated assembly of these components is all handled, it all contained under one roof. We make up, and it's also fairly heavily automated compared to a non-automotive style application or process or plant. We make about 2.7 million of the load centers a year, and we make about 800,000 safety switches a year. So as many of you who have aged facilities probably recognize, you often find in your operations, your factory floors, the fact that different departments evolve at different rates. It is very common to have one department reporting performance in a different method than another department. Very common for one department to be storing something on paper, one department to be storing something in Excel, another department storing something or data in a SQL spreadsheet. It's very difficult to share that data back and forth between departments to make rapid decisions on it. And that's the type of scenario that we had here in Lexington. And I mentioned earlier that early in 2019, we sat down with the plant staff and we tried to identify what are your problems that you have in the facility that we can solve with this digital tool bag developed in the Smart Factory program. And the overriding theme that came from the plant staff and the factory leaders was the fact that they didn't have access, free access, easy access, the ability to share data on the operating floor. And as a perfect example, the first use case that I want to talk about is how we started simple here in Lexington. And it was an IIoT simple use case. The Lexington, Kentucky facility has a massive conveyor system known as a power and free overhead conveyor in the plant. At any given times, there are about 7,000 parts that are in process from the fabrication group to the final assembly group in the plant. Those parts are tracked with the use of an EcoStruxure RFID tool and Schneider Electric PLCs in the system. However, the leaders, supervisors in the assembly line applications had very limited access to the WIP levels or the work in process levels that existed from one fabrication zone to an assembly zone. They often found themselves having to move throughout the factory floor. On a given day, they'd have to stop by a computer. They'd have to run over and generate a report to see how much material was coming to them to be assembled on their final assembly process. So we started in Lexington with just 12 signals. We took 12 signals and we extracted those data points for 12 inventory levels for one particular flow in that power and free conveyor system. We extracted it with a tool known as EcoStruxure SCADA Expert, and we pushed it into a data platform known as Aviva Insight, which is a cloud platform. Now, what we gave is we gave the supervisors and the leaders the ability to receive that and have a mobile look at that data. We created content for descriptive analytic charts that showed the trend of that work in progress, what level it was currently at. We used the EcoStruxure SCADA Expert at the edge to stream that data continuously from the process, and the operators and leaders had that data on their phones. They were also, or their tablets and their mobile devices. They were also able to set personal alarm limits on the level of WIP that was problematic. So now, supervisor or leader could get a personal push notification no matter where they were at, in the facility, at home, driving to work, anywhere, that would tell them you're going to have trouble in 18 minutes because of your WIP level if something's not done. They were able to take the manpower and the labor on those assembly lines and shift the labor to other areas. They were able to build different products until the until the WIP levels increased back to previous, back to good levels. In that fashion, they were able to reduce in that stream unplanned downtime reduction by 6%, an immediate labor productivity benefit. It was less than a year return on investment on simply connecting those 12 data point signals. But more importantly, what I want to stress is that it drove an explosion in use cases. When engineers, maintenance technicians, and supervisors saw how easy it was to share that data and make those decisions, we went from 12 data points to 1,300 data points in a mere 18 months. And we're now streaming 1,300 different data points on a real-time basis in the factory. So we started small and we showed the benefit. It sparked ideas and the Lexington facility took off. We also we were able to build on that connectivity and begin looking at some of the next level smart factory tools. Many of you have processes that are proprietary in nature. They're centers of tribal knowledge where only certain individuals know how to plug into a piece of equipment, to troubleshoot it, how to get information out of that piece of equipment. We implemented a tool known as Augmented Operator Advisor, which uses an augmented reality overlay of the tablet's image of the machine with real-time data streaming from the machine. We were able to do that after we had that IoT connectivity background. Now, an operator or a technician can take a mobile device and they can walk up to the piece of equipment, hold their mobile device hold their mobile device in front of them such that the camera on the mobile device sees the equipment, and instantly real-time data like temperatures, vibrations, alarms are streaming to them in a real-time fashion in an augmented reality view on the tablet. We digitized the electrical and mechanical documentation and delivered that in digital format through the use of this tool too. We knocked down those tribal knowledge centers and we made it easy to share that data and to troubleshoot those pieces of equipment. And we saw a 20% reduction in the mean time to repair in those pieces of equipment. So not only building on that IoT connectivity, has allowed us now to begin the next level or the next stage of the journey, and that's advanced analytics. Okay, I spoke briefly about how we had connected 12 signals to begin with and 12 data points into a cloud platform to begin descriptively analyzing those points. I also mentioned that we reached 1,300 points at the end of 2020 that are streaming continuously. One of those data points, or a few of those data points, concern temperatures in some of our critical equipment. In this example, we took a welding machine, which is an automated welder, fairly complicated, performing a spot welding process and making a load center, performing spot welds on a load center at a cycle time of a product about every 6 seconds. And what we did is we were able to take those temperatures that we now had historized in that cloud data platform provided by Aviva Insight. We're able to train a machine learning model on those temperatures and begin to detect anomalies when those temperatures begin to move outside of the norm. Using Aviva guided analytics, we're now able to train a machine learning model and deploy that model in the cloud tool. And the result of that model is a real-time health calculation that gives us a percentage of the health of the equipment. When that health ticks above a certain level, we know that we have weld cable problems. We've already been able to catch one occurrence in the facility where we had a pending failure and we were able to correct it, which helped us reduce our downtime there in the machine by 4%. But understand that this is an evolution. We built the level, we built the foundation of the IoT connectivity and the data extraction, and now we're moving on into the next level or the next stage. We also utilize the IoT connectivity in the facility to improve our sustainability. And of course, this is on the front of everyone's mind now, and it's very important for us to focus on sustainability. We use a series of connected meters here in the facility to measure and monitor where we use our energy. And we use two very important tools in the facility known as Power Monitoring Expert and Resource Advisor. Power Monitoring Expert is a tool that resides at the edge, and it uses the data from those connected meters to give us an indication of exactly what level of energy was spent at what point. EcoStruxure Resource Advisor takes that a more of a regional look at that energy and compares that energy usage to like processes, gives you analytics across, compares it to ambient weather temperatures, volumes that you're producing. In this fashion, we've been able to find and correct mistakes in our processes. As an example here, I show some graphs. I realize they're kind of small to see, but we've seen this is an example of where we noticed our natural gas consumption in the facility was abnormal for the given capacity in year, or the given volume in year over year that we were producing. We took a closer look at the system, and we found out the algorithm that controls some of the fans in our paint system was wrong. We were able to correct that and say and achieve a savings on that. In this fashion, these types of analysis, these types of descriptive analysis and finding out where your energy is being used or wasted, we've been able to use these types of tools to utilize, to achieve 26% energy savings here in the facility since the maturity of these tools, and even reduce our CO2 footprint with use of renewable energy credits by 78%. So we're very proud of that. We're very proud of that connectivity, that once again, that progression on the base IoT connectivity to drive sustainability. I do want to spend a moment. We said we would touch and come back to cybersecurity, and it's something that can't be taken lightly. What we found, some of the lessons that we learned, particularly here in Lexington, but at a global level, there is much misunderstanding when the IT worlds and the OT, or operational technology layer, worlds converge. The operational technology layer being those of us that are in the factories and handle the machines and the processes, and the IT layer that generally handles the office computers and network devices. We found that it is very important, critical in terms of cybersecurity, to develop an IT team or IT department that is very good at working with trusted partners, certified vendors, and they establish standard architectures. And by that, I mean that they work with partners software vendors who are established. They are following the correct standards for the software development. They're using the right cybersecurity protocols for information that travels back and forth for data that travels back and forth between these layers. And this team is, this IT team is very, very crucial in ensuring that those software partners and software vendors provide the evidence that that is taking place. Okay, that's very critical that we established a certification process for the software that we've implemented in our facilities. We also found it very important to establish a rigorous device management program. A lot of this technology involves the use of mobile devices on our factory floor. We find tablets, cell phones, some personal, that are brought are assigned in a business type role in the facilities, and also company mobile devices that are issued to employees. The control of those access and credentials is very important. And we're fortunate enough to have developed our IT team here within Schneider Electric into a body that has a very rigorous management program for those devices and the management of those devices on our networks. We also find that at the OT layer, that cybersecurity is often an afterthought. How many times have you walked your factory floor and you've seen passwords written on a piece of paper or a sticky note or a monitor slid underneath the keyboard? That's a common thing that I've seen in the past, and it has to be stopped. It has to be stopped by driving home cybersecurity awareness through training, okay, and rigorous training and of examples of what the lack of cybersecurity can cause. And unfortunately, we have more and more use cases, or more and more cases now of what the lack of cybersecurity awareness can cause. So that has to come as a prerequisite. Cybersecurity has to be driven through awareness and training to those folks in the OT layer. There also has to be governance of those folks in the OT layer, the shop engineers, the controls engineers, on the architecture adherence and application certification that I've spoke of in the IT world. It's very important that your smart factory program or your digital factory program establishes an architecture to follow on how to connect your equipment, and an application certification process on how to certify the softwares that you're going to work and ensure that it's cyber secure. And then it's also very important that those that manage the OT layer ensure that their members are following those architectures. They're scaling the applications to a standard architecture, and they're following that application certification process by interacting with the IT group. So I've spent a lot of time on cybersecurity there, but these are some lessons and some things that we learned early on. Some of these you may not have thought of. Some of them seem to be common sense, but some of the things that we ran into and fought through in our digital transformation, particularly here in Lexington, Kentucky. And finally, I want to make a note and come back to one of the roadblocks or difficulties to get through that we talked at the beginning of the presentation about people and change management. It's not all ones and zeros. So it's not just a matter of implementing a software package that does all the latest, greatest things and then walking away from it. The people who are implementing your smart factory tools, who are in charge of driving that digital transformation, they need to have a good change management aspect as well. They need to be able to engage employees to take the fear of a new technology away from that employee, and that's generally done by over and over and over re-engaging that employee until there is no more fear and the technology can be adopted and can help the employee improve in their everyday jobs. That's very important. I can't stress enough the change management piece. It's just not all ones and zeros. You have to have acknowledgement of the people factor and make sure that you're bringing the people factor along and improving it as well. So I'm glad you had that I had a chance to speak with you today. That fairly sums up my discussion here about our brownfield facility. We're very happy about, very proud of what we have here in Lexington, Kentucky, and we would really love to have you visit the plant. We are giving virtual tours now in the facility, but I'm very hopeful that we'll have in-person videos or in-person visits very soon. Please contact your local Schneider Electric distributor to set up either a virtual tour or a upcoming in-person tour at the Lexington, Kentucky facility. And we'd love to have you. Thank you so much for your time.